So we've made it to the final gas of gas chemistry. So we've looked at nitrogen, hydrogen, oxygen, and now we finally come to carbon dioxide. It follows the same pattern as the other gases, so we'll start with its formula, CO2, and its physical properties. It's another colourless odorless gas, as are all the gases that make up air. It is, like oxygen, and slightly different to hydrogen and nitrogen, is slightly soluble in water. You might remember us talking about fizzy drinks having carbon dioxide dissolved in them. Those fizzy drinks are acidic because when you dissolve that carbon dioxide, it being a non-metal oxide, they generally are acids, so we get slightly acidic solutions. Also slightly denser than air, it's quite a heavy gas. It's got a larger kind of mass than nitrogen or oxygen. I'll come back to the test. I know it's here in notes at the start, but we can come back to it in a second. It's a little bit complicated. Start with the preparation because it's a little bit more familiar. What we use to make carbon dioxide in the lab, again, uses a reaction we already know about. What we looked at in the acids topic is if you take a carbonate and react with an acid, you make a salt plus carbon dioxide plus water. Obviously, the important thing there is we're making carbon dioxide, which is what we want. So the kind of approved method of making it in the lab, we'll take calcium carbonate, which is like marble chips, add some acid to it, it'll produce some gas, and we'll be able to trap that. Again, how do we trap that gas? Same as before, we use downward displacement of water. This diagram here, maybe don't like it as much as the other ones. We probably should have a beehive shelf here and maybe a gas jar rather than a measuring cylinder, but gets across the same idea. This is filled with water. The carbon dioxide is going to bubble through the delivery tube, get to the top of the gas jar and push out the water that was inside it, so that's known as downward displacement. Observations just before, you get that colourless gas, you get fizzing, the calcium carbonate will disappear and heat will be given off. So that's how you make carbon dioxide. Now, whenever it comes to the test, that's not actually that new. We've looked at the test for carbon dioxide before. It should have been drilled into you since probably year 8. You're going to bubble the gas through lime water and the lime water will turn milky. So that's nothing different there. What we're going to add to that is the actual chemistry that's going on when we do add or do bubble carbon dioxide through water. So first of all, what lime water is probably a wee bit new to you. Lime water is a solution of calcium hydroxide, so CaOH2. If you dissolve that in water, it makes lime water. What happens when you bubble carbon dioxide through lime water is that the carbon dioxide reacts with that calcium hydroxide. So a chemical reaction takes place, which is described here, and this is the reaction you do need to know. CO2 plus CaOH2 goes to calcium carbonate, CaCO3 plus water. The water's not too important because it's already dissolved in water, it's just like a wee byproduct, but this bit is important. Calcium carbonate is what you might call, again, marble chips. It doesn't dissolve in water. So what you've got here basically a gas and an aqueous solution turning into a solid. If you try and sort of visualize what that'll look like, so a colourless gas with a colour solution, if you make a solid from those two things reacting together, it's going to turn your solution cloudy because you've got wee kind of particles of solid being produced within your solution. And that's what makes lime water turn milky. You're basically making marble chips, or like what you might call chalk, in your solution. So that's the justification for the lime water test. One other new thing about the lime water test is this next thing. Something you've never really been shown before, maybe. Again, you might have been. If you have that lime water test, but you keep on bubbling lime water through, so even after it turns milky or cloudy, you keep going, something else happens. Whenever you bubble more carbon dioxide to the mixture, the precipitate actually disappears and it turns back to being colourless again. So it's turned cloudy, and then if you keep going, it turns back to being colourless. The reason that happens is actually a second reaction taking place in the solution. So in the first reaction you made calcium carbonate, that's what turned it cloudy in the first place. If you react that with more carbon dioxide and more water, and there's plenty of water in the lime water solution, you'll make a new chemical called calcium hydrogen carbonate. Again, don't worry that this is new, it's just a new chemical reaction. Calcium carbonate's got the formula CaHCO3 twice. Remember, the hydrogen carbonate ion at the back of the periodic table has got a minus charge, Ca has got 2 plus charge, so swapping and dropping gives you that formula. Why that's important is that when you've combined these different species together to make your calcium hydrogen carbonate does dissolve in water. remember calcium carbonate doesn't, it's a solid, but you're turning it into a form which does dissolve in water, and that's why it goes back to being colourless again. You're taking away your cloudiness, your solid, and turning it into a solution again. So the lime water test we haven't changed, it is still the same thing. That's how you test for carbon dioxide. All we've added is a couple of detailed chemical reactions for what goes on in the lime water when you do that test. Moving on, like the other ones, we've got a couple of uses of carbon dioxide. First one you might be familiar with is fire extinguishers. So carbon dioxide does not support combustion. So if you sort of blast some carbon dioxide onto a flame, the flame is not going to be able to burn. In the absence of oxygen, you can't get combustion taking place. So fire extinguishers is one important use. Fizzy drinks we talked about a few times, so it dissolves reasonably well in water, not that great, but it causes fizziness when the bubbles come out of the solution. And the third one, quite an interesting use, is dry ice. You might see those kind of like that sort of smoky effect you get from dry ice. It's basically a solid form of carbon dioxide, similar to kind of liquid nitrogen. It's very cold. It's used to keep things cold, like ice cream. So that's another reuse in dry ice. Final wee point is the chemical reactions of carbon dioxide. Again, we've already kind of looked at two of them with the lime water test, but one final one is just that reaction when you dissolve it in water. So imagine we're talking about fizzy drinks here. You've got your water solution, if it's a fizzy drink, or just pure water. If you add carbon dioxide to that, which is basically dissolving, because carbon dioxide is a gas and water is a liquid, you'll make a solution of H2CO3. H2CO3 is called carbonic acid. It's a weak acid. So it causes your acidity in any kind of fizzy drinks. So carbon dioxide is quite a simple one to finish with. Same kind of physical properties. It's soluble more though, and it's acidic. We make it using the reaction of marble chips with acid and trap the gas by downward displacement. The test we got a little bit more detail for. It's still a lime water test, turning lime water milky, though we've added the chemical reactions for that. Lime water is calcium hydroxide, CaOH2. The first reaction that turns it cloudy is that you making calcium carbonate, which is solid, but we've since learned that if you keep on bubbling through the carbon dioxide, it goes back to being cloudy because the calcium carbonate turns into calcium hydrogen carbonate. The final thing is uses, fire extinguishers, fizzy drinks and dry ice as a coolant. And the final thing is when you dissolve carbon dioxide in water, you make carbonic acid. Just need to know the specific formula for that, H2CO3.